All right, we're going to talk about solving systems today using estimation. Before we do that, let's just kind of review what we've been talking about the last few days about graphing a couple of systems and then seeing where they cross and finding their solution. Now, in this first system that we have here, we have a y-intercept of -3. So I'll mark that. We have a slope of up 1 over 2, or 1/2. Up 1 over 2, up 1 over 2. So I'll grab my line tool down here and just kind of sketch a line between those points. So that would go right out. Well, that you get the idea. That wasn't my line tool, but there you go. So the next one, we have 5x plus 4y equals 16. We're going to need to solve for y on this one. So minus 5x from both sides. So when we write that out, then we're going to have 4y equals minus 5x plus 16. And then when we divide both sides by, or everything by 4, like that, we're going to end up with an equation y equals negative 5/4 x plus 4. So there's the equation that we're graphing. So we got to go back and grab our marker and let's go ahead and graph that particular equation. So we start out at +4, and then it says go down 5 over 4. So 1, 2, 3, 4, 5, 1, 2, 3, 4. And in a very nice fashion, these two intersect right there. So the solution would be 4, -1. All right, on this next one, we're asked to find the x and y intercepts. So to do that, we basically break it into two different equations and just set the x part equal to -4 and the y part equal to -4. And so right off the bat, we can see that y equals -4. So the y-intercept is -4. Meanwhile, on the x part, to find the x-intercept, we still need to divide by 2. And that gives us an x-intercept of -2. So we go to -2 on the x-axis and make a dot. And then we grab our line tool and we get a line and we just sketch a line between those 2 points. And it's nice if you extend it in both directions, because really the line does go on forever in both directions. So something along those lines, okay? So that's how you do it if you're finding x and y intercepts. So now today we're gonna find some equations that didn't quite cross in a comfortable spot, and we're going to try and estimate their solution. So let's practice that a little bit. So let's start with our first equation. We have a y-intercept of 2. So we'll mark that with a 2 right there. Then a slope of up 1 and over 4. 1, 2, 3, 4. And then I'm going to graph this next one first. It has a y-intercept of -1. Let's do that in a different color. -1. And then it has a slope of down 1 over 1, down 1 over 1, down 1 over 1, or up 1, back 1, up 1, back 1, up 1, back 1. So I kind of created a little line of blue dots there for that. So I'm going to grab my line tool And so we'll start with our red line. Our red line's going to come down through here. Something like that. And I've got kind of a fat line. Maybe we better make it not quite so fat so we can actually see where it's going. Okay, and so if you notice, we're just a little off on a couple of our points. So I'm adjusting that. All right, so there's our first one, 1/4 x plus 2. So let's do our second line and find out what we come up with. So let's go ahead and just do a regular line, and then we'll see. Okay, so we're going to go between the blue dots here. So if that comes down through there like that, that is our line. I'm going to go ahead and extend it out on both ends. But we notice, kind of disappointingly so, that it doesn't quite meet on an intersection. So it's hard to tell what that intersection is right there. So we just have to estimate. So to me, looking like I have to go back to about negative 2.5 and then up about 1.45, something like that. So the best you can do here is just estimate that. So these two cross at negative 2.5 and approximately, right there, depending on how good our graph is, about 2.3 or something like that, 2.2. Now we could have just said, oh, let's just round it up to 2.5, but that may or may not be accurate. So you're going to just do the best you can and estimate it. And when you do these on ALEC, sometimes if your estimate's close, they'll accept your answer. But we have a little bit of a flexibility of how close we can be. So what if, like we said, if it's kind of in between there like that, you just have to do the best you can. There are actually ways to find the exact solution, but today we're just graphing and coming up with a partial solution or an estimated solution. So let's look at this one. This would be about 1.6 over 1.6 or 1.7 and up about 0.2. So if I was just looking at it and trying to guess about where that would be, so you get the idea. Okay, so we're going to estimate the solution to the system using a graph without your answer. Write your answers in ordered pair. So this one right here, what would that be? About minus 0.6 and a minus 0.6 or so, or 0.7. I'm just going to just say, okay, minus 0.6 backwards and minus 0.6 downwards. Now, if you said 0.65 or something, you're going to be close. And that's all we're trying to do is get close here on these estimations. How about this next one right there? That looks like it's just a little bit beyond the halfway point between 9 and 8 and 10. So I'm going to say my x coordinate is going to be about 9.3. And my y coordinate, well, that's not very high. It's just going to be about 0.15. Again, these are just estimations, trying to get as close as I can without knowing exactly what it is. Okay. Here we're going to actually make the graphs. So we're going to start out at negative 2. We have a slope of up 1, 2, 3, and over 1. Up 1, 2, 3 over 1. And we'll go ahead and graph that one so we don't have too much else in the way. So this one starts, oops, I got to get the line tool instead. So I'm going to grab the line tool, come up through there just like that. Make sure it's as accurate as I can get it. And that's pretty good right there. So there's my first one. That's y equals 3x minus 2. The next one is y equals negative x plus 3. So let's graph that line. So we grab another color. We go up to plus 3. And then the slope says go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. So there's a line of points that we can use. So now if we go ahead and draw a line, let's get us a couple more points in here. If we go ahead and use that line of points to graph that line, we notice we end up over here. That's going to be pretty close to about 1.2 and 1.5. So I'm just estimating. When I say 1.2, I'm looking at it's about 1/5 of the way across that between 1 and 2. That's where I came up with 1.2. And then the other one looks like it's about halfway between 1 and 2 going in the y direction. So 1.2 and 1.5. And that's the idea here. You're just estimating, trying to figure out how close you can get. Let's do one or two more. We'll start out with -2 for our y-intercept. Up 1 over 1, 2, 3, 4 for our slope. Let's go down 1 and back 1, 2, 3, 4. All right, let's go ahead and grab our line tool and graph that one. And you can see we got that kind of going out in both directions. All right, let's try the next one. And on the next one, you notice it isn't solved for y, so let's go ahead and solve it for y. We end up with 2y equals 12x plus 6. If we divide everything by 2, we end up with y equals 6x plus 3. Okay, let's go ahead and graph it. We'll get a different color. We're going to go up to 1, 2, 3 and make a dot. Then we're going to go, can't go up 6, so we're going to go down 1, 2, 3, 4, 5, 6, and back 1 to get our slope of 6. Let's draw a line then. So between those 2 points, we're going to sketch a line. And we'll extend it out just a little bit to give us make sure we got a pretty good accurate line here that runs through those 2 dots. Okay, now that we got our line in place, we look and see, and it looks to me like it's at about -1. I'm looking for this little dot right here. Let me mark that a little bit better with a different color. So that purple dot looks like it's at -1 and -2.2. Something like that, somewhere in that neighborhood. And so if you do that, that'll be good enough on this particular one. So we're going to give you a little worksheet, and you're going to just practice a few of those problems. And the best thing to do is make sure you get your very best graphs, and then go back and estimate about where they cross. Thank you very much.